Welcome back. Last time, we learned about gradient descent, the process of walking downhill to find the lowest error. But how do we calculate the downhill direction in a network that's hundreds of layers deep? The answer is a beautiful piece of calculus called the chain rule. Let's first understand the problem. A deep neural network is a series of functions nested inside each other. The output of layer 1 becomes the input for layer 2, and so on. We can easily see how the last layer affects the final error. But how do we know how to adjust the settings of the very first layer? Its effect on the final error is buried under all the other layers. This is the challenge the chain rule solves. So what is it? The chain rule is a simple rule for finding the rate of change of a function of a function. In AI terms, it allows us to untangle the nested layers of a network and calculate how much each individual setting, no matter how deep, contributes to the final error. The name is perfect. It lets us measure the effect of a whole chain of events. Let's use a simple example. Imagine a change in A causes a change in B, and a change in B causes a change in C. We can calculate how much A affects B, and we can calculate how much B affects C. The chain rule tells us that to find the total effect of A on C, we just have to multiply those two individual effects together. It's that simple. This leads to the magic algorithm at the heart of deep learning: backpropagation. Don't be intimidated by the name. Backpropagation is just the process of applying the chain rule efficiently, backwards through the network. We start at the end, with the final error, and pass that error signal backwards, layer by layer, to figure out how much blame each setting gets for the final result. The entire training process is a continuous two-step dance. First is the forward pass, where your data flows into the network and a prediction comes out the other end. Second is the backward pass, where the error from that prediction flows backwards through the network. The chain rule is used during this backward pass to calculate the gradient for every single setting. Finally, the model uses these gradients to update itself. The chain rule is, without exaggeration, the core mathematical engine that makes modern deep learning practical. It's the elegant trick that allows us to train models with billions of parameters. You now understand the heart of how neural networks learn. In our next lesson, we will begin exploring the third and final pillar of AI math: probability theory.